Throughout my career, I've worked in different roles for various different organizations, both indirect and directly, but typically supporting always the core functions that are responsible for providing, services back to the business centered around data and AI. Now, if I kind of reflect back on my time, through all those different roles, while certain things have definitely chopped and changed in terms of tools, technologies, and processes, and just kind of patterns of doing things, right? We've transitioned from, the SQL traditional way of the data warehouse to the data lake to lakehouse and other kind of data patterns. But one of the kind of primary driving factors that I think has ultimately remained unchanged, throughout all those different roles is how do we really empower people in organizations to derive business value through actionable insights. And in order to do this effectively and in order to do this at scale, we really need to get a handle on our data. And so my name is Tegan Riffat. I work at Microsoft as a cloud solution architect, and I specialize in the subset of services within Azure that help customers in the data and AI domain. So whether that's, ingest, persist, enrich, and ultimately looking to serve data back to be consumed, whether that be by people, processes and applications. In this particular session on Harness the Power of Data with Azure Data and AI, I'm hoping to share the broad spectrum of capabilities that we have within the Azure Data and AI portfolio. We've got things from various database technologies to IoT to machine learning and a lot more. And so we'll be looking at how these products and services fit basically within the fundamental building blocks of a modern cloud-based data solution. So just to take a step back and set a little bit of context, when we think of the current state of organizations who are either looking to embark on their digital transformation journey or, progress based on where they are at the moment, we have an increasing number of organizations who are looking to adopt or execute against a cloud-first strategy. And in this context, we are having to contend with data that's coming in from like a variety of formats, a variety of different sources, and overall data volumes just growing at an exponential rate. And so we have the IDC, for instance, who are predicting that the collective sum of the world's data will grow to 170 zettabytes, which is like a mind-numbing number by 2025. And we're also seeing accelerated levels of interest and investment in areas such as artificial intelligence, with worldwide spend expected to double over the next 4 years. And so really it's this combination of these three core ingredients, right? We've got cloud, we've got data, and we've got AI, where we're able to ingest data at scale, regardless of what the source is, of any format, into this unified data estate. And that's something that the cloud empowers and enables. Where in that unified estate and in the cloud, we have essentially access to limitless compute, limitless storage, and modern analytic capabilities. And where we're able to also use artificial intelligence, right, to reason over that data in order to unlock those deeper, those more meaningful insights that may be laying dormant in our data. And so really it's organizations that can harness these kind of three core ingredients who are going to be really well positioned to capture a competitive edge. So if we just take again another step back and have a look at the overall data to action journey, which as you can see on the slide, it follows usually a fairly typical pattern. So on the left-hand side, we have data coming in from a variety of sources and also a variety of formats. So whether that is unstructured data, such as media files like images and video and audio, or we may have some semi-structured documents such as JSON, right, which might be coming from a web-based RESTful API. Or we also may have really structured information such as relational data that we might be a lot more familiar with, structured in rows and columns and being written from those line of business applications. And so regardless of where this data is coming from and what source and format it takes, the initial step is to ingest this into our estate. And so we've got various services to help facilitate that. And once we've done that initial ingestion, how do we persist this in some type of data store in order for later retrieval, so that we can kind of derive more value from that data? Now, Once we do have data in storage, we can leverage various analytic capabilities to perform transformations, draw insights, but ultimately, visualize and surface these insights to be actioned by people, applications and automated systems. And so, scattered across this diagram, we have a variety of Azure services that sit across these various buckets, and we'll kind of dive into these in a little bit more detail on the next slide. So, drilling in further into Azure Data Services, while this is not an exhaustive list by any stretch, it is a good representation of some of the kind of fundamental building blocks that comprise a modern cloud-based data solution. And so, some of these components, such as Power BI, you may be a lot more familiar with, but others, such as maybe Azure Synapse Analytics or Azure Cosmos DB, potentially less so. But we're going to kind of step through this as we go along. And really, the aim is to demystify, these services down to their core purpose as to when and where we may use them. And we'll work our way from the bottom up. There is no really kind of specific order that we have these services listed on the side. They're loosely aligned to that kind of ingest, persist, enrich, and serve. But we won't get too bogged down in the particular order that we're running through things. So first one's first. We'll start from the bottom with Azure Purview. Now, if we picture the typical data estate for any organization, it is very common to be comprised of many data assets from not just, obviously, it's not going to be Microsoft head to toe, even though we'd like to maybe think that. We're probably going to have data assets from multiple vendors, right? So Microsoft, there may be some Microsoft technologies in there, but we'll have some Oracle, SAP, Teradata, and so on. Now, some of these assets may reside on premises. For some customers, it may reside on premises as well as in the cloud. So we may have a hybrid estate going on. And for some customers, we may even have multiple clouds. We may have a little bit of Azure, a little bit of potentially, AWS or GCP and so on. And so within these types of organizations where we have like hybrid estates in the true sense, how can we empower the typical information consumer in order to find what matters to them, right? If I'm looking for a data set that really matters to me across when I've got so many things spread across all these different sources, how do I find what is important to me? And equally important, if we fill in the role or the shoes of the chief data officer or the VP of data analytics, it's not only important as to what exists and where did it originate from, but also how do I get a holistic view over where my sensitive data resides, and is that data being used in a compliant way? So we need a mechanism to answer these types of questions and facilitate those types of scenarios. The good news is that within these types of data assets, we have a lot of useful metadata that can be used to describe the data, right? And so if we take a relational SQL database, for instance, within that database, we'll have schemas. And within those schemas, we'll have tables and views. And within those tables and views, we'll have columns. And all this kind of metadata along the lineage path can help us kind of describe the data and help us kind of find what we're looking for. So Azure Purview is one of our newly released Microsoft products in public preview, and ultimately it's a fully managed data governance service that enables us to build this holistic data map. So regardless of where the data resides or what format it takes, having this kind of holistic map of the entire estate and helps us facilitate such like data discovery scenarios. And so the way I like to think about this particular layer is either dock it or document it. Azure Data Factory and Azure Data Share, these are our data orchestration or data movement services. So if we're looking to move data from, say, source A and we want it to get over to destination B, these are one of the two types of services that we potentially may use to facilitate something like that. So that might be moving data from on-premises to the cloud. You may be moving data between clouds. So there might be some stuff that's sitting in an AWS S3 bucket and we want to move that to blob storage, or potentially within Azure itself, between services. So we may want to move some data that exists in the data lake and have that kind of persisted within the Azure SQL Database to kind of serve a different application, for instance. Now, in the context of Azure Data Factory specifically, this activity can also encompass the calling upon of computational services like Azure Databricks or a stored procedure within Azure Synapse Analytics to perform some type of transformation as part of that overall kind of pipeline. And this is commonly referred to as ETL, extract, transform, and load, or ELT, extract, load, and transform. And so the way I like to think about this particular layer is move it. Moving up to Event Hub and IoT Hub, these are our real-time data ingestion services, with the latter, so IoT Hub, having extended functionality to cater for IoT devices specifically, things like bidirectional communication. So let's work with an example. We have a large water utility company, and this particular water utility company is looking to proactively identify leaks that occur in their pipes before they happen. Now, in order to kind of bake in this particular type of intelligence, we need to really capture the right data first. And so what this utility company has done is that they've deployed a fleet of IoT devices with some sensors attached across their pipe network to kind of capture the right bits of data in order to make these types of predictions. Now, if we zoom in onto a singular IoT device that's attached to just one of these pipes, which is generating data via sensors, and in this instance, we might be detecting, say, water pressure that's on the pipe. That packet of data in and of itself may be quite small, right? We take a particular reading, the water pressure is, say, like 85%. But as we start to kind of step back, we realize, well, what's the frequency at which we'll need to be logging that? That's probably not a once a day activity. That's potentially happening multiple times per second. And then what's the multitude of devices that we have across our fleets? That's another multiplication factor, right? We've got IoT devices deployed across the entire pipe network. And then further to that, potentially these devices are not just logging one type of sensory information, but we might have multiple sensors, maybe like soil moisture, maybe things like just the overall temperature. And so very quickly we're scaling to, if not thousands or hundreds of thousands, or potentially even millions of events per second in which we need to ingest somehow. And so this is where these big data streaming platforms such as Event Hub and IoT Hub really kind of step in, and they act as that initial point of ingestion into the cloud to kind of handle the brute force of all that data that needs to be ingested. And so the way that we can think about this layer is bring it. Azure Data Lake Storage and Azure Blob Storage, simply put, these are our just general purpose data stores, right? They're really, really scalable by design to the tune of exabytes of data. So hitting kind of storage limits from a volume perspective is like a non-issue. They're generally very, very cost effective, and we can store data of any type, right? It can be an XML file, a Parquet file, a CSV file, it doesn't really matter. Azure Data Lake Storage in particular has extended functionalities such as hierarchical namespaces, and that makes it perfectly suited for those big data and analytic workloads. We want to process things in parallel. And so the way that we can think about this particular layer is simply store it. Moving on up to Azure SQL Database and Azure Synapse Analytics and Azure Cosmos DB. These are our various different types of data stores crossing both SQL and NoSQL workloads. And so, well, you may be thinking, right, Tegan, you've just explained data lake storage and blob storage. There is a little bit of overlap here in the basic sense that they also do store data, which is true. But you'll typically find that these types of components are optimized to serve something in particular. And so that might be the underpinning of a line of business application that needs to write a lot of records to an OLTP kind of optimized store. We may need something that's reading quite a lot to facilitate, enterprise reporting requirements. We have a lot of dashboards and reports kind of querying maybe something like Synapse. Or we have like a web application that needs really low latency, down to like a couple of milliseconds, and it might be serving a web API. And so something like Cosmos DB might be better fit for purpose. So with that all in mind, I'd like to think of this particular layer as serve it. HD Insight, Azure Databricks, and Azure Data Explorer. These are our big data, analytics platforms, and a lot of them have support for open source distributed computing frameworks such as Apache Spark. Now, while there's various reasons why you may choose one technology over the other, some of the things that they have in common is essentially the ability to process large volumes of data. And typically they do this through the spinning up of clusters, or these computing clusters, which have the benefits of parallel processing. And that's something that is common across a lot of these services. And so the way in which we can think about this layer is simply scale it. Stream analytics, when we think of real-time streaming, we spoke about streaming a little bit before, and so you may be thinking, okay, well, we need to leverage our previously mentioned components such as event hubs or IoT hub, which is absolutely true in terms of that initial point of ingestion. But that said, we may want to query the data as we're receiving it in real time. So not just being able to ingest it, but how do we actually query and ask questions of that data as it's being streamed? And so if we go with another example, and in this instance, we have now a new financial startup, right? They're a bank startup. They offer credit cards to their customers, and they're streaming and ingesting these credit card transactions as they're occurring in real time. And what this particular startup would like to implement is some form of fraud detection. So one really simple example of that is, say, well, we've got these two credit card transactions, one and that occurred over a certain period of time. So one may have occurred at midday around lunchtime, and the other one occurred at 1:30. But the locations logged for these two different locations, well, one was in Spain and the other one was in Sydney, Australia, and so the elapsed time and the physical distance between those transactions is impossible to travel, over that period. And so we may want to raise an alert to say, well, this looks like something's dodgy happening here, so we want to raise an alert and say this is potentially fraud. So this is where Stream Analytics as a service can be used. We can express business logic in the form of SQL statements to query the data as it's being ingested in real time. And so the way that we kind of express this layer is stream it. Azure Machine Learning and Azure Cognitive Services, these capabilities enable AI at scale. So we've got, when we talk about Azure Cognitive Services, Microsoft's done all the hard work, right? You don't need to hold a doctorate. We've got a bunch of pre-built models across a variety of domains, from language to vision and to speech and many others. Where, again, like Microsoft has done all the hard work, we've built these models for you, so you can simply kind of infuse that intelligence into your existing applications. And so this is our model, your data. Now, on the other end of the spectrum, we have things like Azure Machine Learning and the Azure Machine Learning Service. And this is great for those highly specialized environments where we're trying to empower your data scientists to achieve more and be more productive with support for all the kind of familiar tools and frameworks that they're already kind of well versed in, and to use those in order to build custom AI models. And so in this instance, it would be your model, your data. And the way I like to categorize this layer is simply as predicted. And last but by no means least, we've got Power BI. And so while we can ingest data, we can persist it in storage, we can move it around, and we can serve it, and we can reason over that data with AI services, at some point we ultimately need to see it. Okay. So hopefully by now you have a better understanding of the various kind of building blocks available to us in Azure to compose a modern cloud-based data solution. And to not overwhelm you, obviously we've ran through quite a bit. It's not to say that each one of these technologies will be required for each solution. Obviously, your mileage is going to vary depending on the specific scenario or customer requirements you're looking to facilitate. But that said, we can ground ourselves in these kind of common patterns that we do see in the modern data warehouse around these kind of various phases of ingest, store, prep, serve, and report. So here we just have an example of some of the usual suspects that can be used to facilitate such a scenario. So starting with ingestion, we've got the Azure Data Factory to do that copy of activity or that data movement. So we might be copying some data from our on-premises environment and then persisting that in something like Azure Data Lake Storage. Now, once our data is persisted, we can then draw on computational resources like those offered by Azure Databricks to wrangle, transform, and enrich our data on a collaborative Apache Spark-based analytics platform. Once our data is kind of prepped and it's ready, we can then load that into something like Azure Synapse Analytics, which can be queried and served to our enterprise dashboards and reports on a data visualization service such as Power BI. Now, Before we transition to our final section on just kind of resources of where you can go to kind of learn more if you want to understand a little bit more about this particular space, one thing I just wanted to call out is what this pattern can also look like based on recent updates to Azure Synapse Analytics, which went GA at the tail end of last year. So as you can see on the slide, the evolution of what was formerly known as the SQL Data Warehouse, now known as Azure Synapse Analytics, brings together a number of modern capabilities now under a single service as it's evolved from what was previously kind of traditionally just the SQL Data Warehouse, right? So from a data movement perspective, we can facilitate integration with things like Synapse Pipeline. When it comes to big data processing, we have the Apache Spark runtime that's part of now Azure Synapse Analytics. And we also have the ability to execute ad hoc queries with serverless SQL pools, like not really requiring provision resources, just be sitting there all the time. And so for context, our previous pattern looked a little bit like this, where we had a number of different services that were needed to kind of facilitate the modern data warehouse with Data Factory. We've got Azure Databricks and what was formerly known as SQL Data Warehouse. And then in contrast, this is what it could potentially also look like with Azure Synapse Analytics, where we're catering for all phases, all within a single service offering. And so whether that's Synapse pipelines for the ingestion phase, the Apache Spark runtime for the prep and transformation enrichment, and then Synapse SQL to serve that to our data visualization layer with Power BI. And so what this ultimately means is that we may only need to provision, administer, and manage a single service, which can potentially drop our TCO quite dramatically. Now, each customer requirement is going to be different, but that is one example of how we can facilitate the kind of modern data warehouse pattern. Okay, so if you're interested in learning more, we have this resource at the skills poster at aka.ms/skills-poster. If we have a quick look at that, where we've summarized all of our modern role-based certifications on a single page across our various solution areas. And so historically, if you're familiar with Microsoft, the certification program, we used to be quite have certs centered around technology. So you'll be certified and validated over SQL Server 2016. But we shifted to that to role-based models. So this should make it really much easier to do skills planning within your team, or if you're an individual looking to understand what are the various kind of skills and technologies I need to kind of skill up on in order to facilitate a particular role. This poster hopefully makes that journey a little bit easier. And you can see we've got all of the Azure certs under one pillar, and specifically all of the data and AI certs kind of grouped up here. So whether that's I want to become an Azure data engineer, an Azure data scientist, and so on and so forth. So yeah, a good resource to kind of narrow down your focus from a certs perspective. And then finally, obviously, prior to undertaking an exam and becoming certified and validating your kind of skills and knowledge, we have Microsoft Learn, which is an amazing resource to kind of prep you before you kind of get to that point. And so if you're interested in learning more, getting hands-on with the technology, Microsoft Learn is a great place for that. All the content is free. It's available on demand. It can be consumed in like bite-sized chunks, and so you can learn at your own pace. And we have content that spans things from beginners all the way up to seasoned professionals. And so, yeah, amazing resource. If you'd like to learn more and get started, head on over to aka.ms/learn. And with that, that brings us to a close. So I just want to finish off by saying thank you.